This video discusses the purpose, core methodology, and advantages and disadvantages of using surveys in political research. I discuss sampling techniques and sources of bias, using examples from the 2016 elections and polling about COVID. At the end of this video, you should be able to define population, sampling frame, and sample, and understand the challenges of selection bias, measurement error, and sample size in surveys. Donald Trump's victory in the 2016 presidential election was a surprise for many reasons, but most notably because pre-election polls gave Hillary Clinton a strong lead over Trump. So much so that election forecasts, such as this one from 538.com, uniformly predicted Clinton would win. There are many reasons why these election predictions were wrong. Some relate to the U.S. electoral system. For example, many polls measured popularity across the nation, and these were actually pretty accurate. On average, polls anticipated Clinton would win 48.5% of the vote and Trump 45%. Clinton ended up winning 48% of the vote and Trump 46%, a difference well within the margin of error. But of course, this is not how the United States elects presidents, and differences in popularity across states meant a victory for Trump in the Electoral College. Other reasons for the inaccuracy relate to the technical details of polling, how different sources of information are weighted or given priority, or they are related to inaccurate interpretation by the media. Media elites expected Trump to lose and read the results in a way that confirmed their assumptions. But it is also true that there were some underlying difficulties in how the polls were conducted. For example, who was included in the surveys, that underrepresented Republicans and Trump supporters particularly. In this video, I will discuss why we use polls and how we try to gather accurate samples of the people we are trying to study. So first off, why do we use surveys? The short answer is that sometimes the best way to find out what people think is to ask them. Surveys allow you to ask large groups of people the same questions. This is great for the external validity of research. Taking a large random sample of the population you are trying to study is the best way to ensure that the results you get actually reflect what people think. But there are some disadvantages to survey research. In order to get a large number of people to complete a survey, you need to ask a limited number of multiple-choice questions. This leaves a lot of room for measurement error. If you ask a leading question or inappropriately limit the range of responses, you will skew your results. It can also be hard to tell when people aren't answering truthfully. And while a large random sample does give you a good approximation of the views of the overall population, it is really hard to get a truly random sample. Low survey response rates often generate selection bias in the results. So surveys have advantages and disadvantages, but let's talk about how to do a survey well. First, some vocabulary. Surveys are all about asking questions of a small group of people in order to understand the views of a larger group of people. We care about 4 groups when we set up a survey. The first is the population. This is the full set of observations, or people, that you want to understand. For example, if we are talking about U.S. presidential election polls, the population we are interested in is registered voters. The sampling frame is the list of people we use to develop the survey. Sticking with our example, it's not actually the list of registered voters. It's the list of registered voters that we have contact information for. Voter registration records are public. It's possible to request voters' names and addresses. But if you want to do a phone or internet survey, you have more work to do to figure out how to contact survey participants. Polling organizations used to develop contact lists using the phone book. But since many Americans no longer have landlines and don't answer their mobile phones, this is no longer an effective way to conduct polls. Most big pollsters now conduct polls over the internet. They generate large-ish sampling frames by contacting individuals via mail and telephone. Polling organizations then sent emails to samples from that list of people who agreed to participate in surveys. So that's the sampling frame. The sample, then, is the group of people that you contact for the survey, the actual group of people that you text or email to participate. Finally, the last group, which is not listed here, is the group of people who actually respond to the survey. I'm going to come back to this later, but the differences between who is asked to complete a survey and who actually does are critical. I've mentioned this sample several times now, but how do we actually take an accurate sample of a population? There are many strategies. I will mention 4, 2 of which are good and 2 of which are less good. For surveys, you want to make sure you take a probability sample. This is when you know the likelihood of each person in the sampling frame being actually chosen for the sample. A simple random sample is when everyone is equally likely to be asked to participate in the survey. Respondents are chosen at random, and that ensures they represent the overall population. But sometimes you don't actually want an exact representation of the population. Recall the survey we read about at the beginning of the semester. The student involved was researching non-citizen voting, but the number of non-citizens who responded to the survey she analyzed was very small. So if you want to study an underrepresented or small group, you often want to increase the number of participants in your survey from that group. So, for example, the Pew Research Center now oversamples Republicans and other groups in their research in order to account for past polling errors. This is called taking a stratified sample. You divide your sampling frame into groups and then randomly select participants from each group in order to make sure you have enough respondents from each of them. I will conclude this section by noting a few less good ways to do polling. Basically, you should never conduct a poll based on a convenience sample. This is a sample chosen based on who is available. You often do interview research in this way, but I'll discuss that in the next video. The problem with convenience samples is that there is always bias in who is available. You cannot be sure if the people you spoke to actually reflect the population. Similarly, opt-in samples also introduce both bias and error. People who choose to participate in polls are different from people who choose not to. Sometimes the results of opt-in surveys are entertaining. The people who opt in to answer internet polls, like the poll created to choose the name of a British polar research ship in 2016, tend to choose results based on what they think will be funny, which is how Boating Boatface won that poll and generated many a meme. So this is funny, but many of the polls used around the 2016 and 2020 elections were actually this type of opt-in poll, which easily generates bias and often includes a large number of bad actors who choose to respond inaccurately. Polling agencies are moving away from this method and increasingly adopting the probability stratified sample that I described above, but this method is expensive and it's not yet common. So I would like to conclude by discussing these sources of bias. There are three main categories of bias in polling research: selection bias, measurement error, and errors related to the sample size, called statistical power. Selection bias happens in two ways. One is when the group of people you contact for a survey doesn't actually represent the population of interest. The list of contact information you generated might not have accurately reflected the underlying population. For example, if you conduct a poll based on landline phone interviews, you will systematically underrepresent young people, who are more likely to only have a mobile phone. Response rates also generate bias. In national polling today, Republican voters are less likely to respond to surveys than Democrats or independents. This gives greater weight to the Republicans who do choose to participate, who may not accurately reflect the Republican base. Again, polling organizations have begun increasing the number of Republicans in a sample in order to compensate, but when one group of people systematically chooses not to answer questions, it generates uncertainty about the results. The second category of bias is measurement error. There are many ways you can generate biased answers. They depend on the questions you ask, who is asking the question, and the honesty of the respondents. The way you phrase a question makes a huge impact on the type of answers you get. We will discuss this further in class, but for now I just want to note that these differences are magnified when you're asking questions across languages and cultures. Ideas like democracy have different meanings in different countries and can be translated in many different ways. The results of a polling question about support for democracy, then, will vary significantly based on the specific words you choose. Even if you ask a good question, you might not get an honest answer. Even on anonymous surveys, people often feel pressure to give the right answer. For example, if you ask someone whether they voted in the last election, they are likely to say yes, even if they didn't vote. This is called social desirability bias. We can see this in the results of polls about COVID vaccines taken during the pandemic. This review of survey results from 2021 that asked whether participants had received a COVID vaccine demonstrates two of the problems I've been talking about. Here, the gray line represents the actual number of vaccines given, the truth, and the colored lines represent poll results for the question about whether someone had received a vaccine. We can see that the top two polls, which were opt-in internet polls, were the least accurate. And we can see that all results were slightly biased upward. People were more likely to give the perceived right response. The last set of problems relate to the number of people in a sample. Your sample needs to be large. The smaller the group, the less likely it is to represent the population. And again, if you are going to analyze subgroups like non-citizens or different ethnic groups, then you need to make sure that each of the subgroups is relatively large. A typical size for a good survey is 1,000 respondents, with individual subgroups having a few dozen respondents minimum. So too small is bad, but so is too large. To return to our COVID surveys, the least accurate surveys had the largest sample sizes. Sample size can't compensate for selection bias or measurement error. As Charles Whelan said about data, garbage in, garbage out. In fact, having an extremely large poor sample is a worst-case scenario. The large sample size will drive the standard error of your analysis down. That's just how the underlying math works. So you will have statistically significant results that are just wrong. So to recap, when you take a probability sample of a population, polling can give you a good estimate of the views of that population. Opt-in samples and interviewer error can generate selection bias, as can poorly phrased questions. More difficult challenges to correct are bias in who responds to a survey and inaccurate responses. Often the best way to get an accurate assessment is to try multiple methods. So next up we will talk about interview research.